All right, so in 4.3, we're pulling the concepts in from 4.1 and 4.2. And we're going to do two-step equations now, okay? So let's talk about what it means to have a two-step equation. Well, guess what? There's more than one step. And you move the term that is not connected to the variable first. Your goal is still to solve for x. Your goal is still to solve for the variable, but now it's not just, oh, well, I add, and then x is by itself, or I multiply or divide. Now we have multiple steps to get that x by itself. Here's the first thing I need you to understand. Whatever side x is on, I have to get everything else to cancel out. How do I do that? Inverse operations. But more than that, I have to know which one do I do first. I add and subtract first. Even write that down. Add and subtract first. Add and subtract first. So that means if there are any terms that can be added or subtracted, okay, so we do that first. That's what I do step one, okay, to get it to cancel to the other side. Well, this is multiplication, isn't it? So I don't subtract to get that to cancel, so it must be the term, again, what I said here in the instructions, that is not connected. Do you see how this is separate? It's not with the term that has the variable. All right, someone once explained it this way. These terms are like best friends. They're like joined together, okay? They're best friends. So the best friends, they want to stay together as long as they possibly can. So we separate them last, okay? I know that's kind of cheesy, but it still kind of drives home the point. I keep these together until the last step. So how could I get positive 4 to cancel out to 0?
Negative.
I do the opposite. Do you guys agree if I subtract 4 that 4 minus 4 equals 0? And my rule says I can do that as long as I do the same thing to the other side. I subtract 4 to the other side. Now I must rewrite my equation. Bring down what's left, 2x. I haven't done anything to my 2x yet. Remember, those are my best friends, okay? So I haven't split them up yet. I canceled my 4, so what's left on the other side? What's 12 minus 4? 8, okay? So now I have to figure out what operation is going to get this 2 to cancel to the other side when I subtract it. Would that be the opposite? What operation connects 2 and x? So what cancels it? Division. To divide by 2. Guys, if you understand what's happening, you will not get this confused. 2 divided by 2 is what? 2 divided by 2. It's 1. That's what I want. I want them to cancel down to 1. So if I divide by that number, do the same thing to the other side, and I have my answer. X equals 4. All right, how do we do on that? I'm trying to slow it down. I hope I'm not confusing you more by slowing it down. Okay, so that is step by step. Add and subtract first, then multiply and divide. And it will always happen that way. Guys, 10 times out of 10. Add and subtract first, then multiply and divide on step 2. Okay, example 1. I'm going to try to start this slow. Okay, just to kind of warm you guys up to these steps. All right. Negative 2x plus 12 equals 4. All right, so again, I'm going to take you through this step by step. I'm not going to ask a lot of questions on this first one. The first thing I do is I need to add or subtract to the other side, okay? Well, you say, oh, I see a negative 2, so I need to add 2. That's a mistake. Because, and here's why, that's the mistake I see time and time again. This is not subtraction, this is multiplication. All right? So that's not what I do first. I must move what is not connected to my variable. Positive 12. I need a minus 12 from both sides. And when that happens, 12 minus 12 is 0. That's great. Step 1 is done. Now I need to bring down what's left. So what would I bring down on the left side? Anybody want to take a shot at it? Hadley? Okay, you're right on the right side. On the left side, I bring down negative 2x equals, like she said, negative 8. Okay, now this is not, okay, again, this is the most common, one of the most common mistakes I see. I see a minus 2, so I need to add 2. That is not the opposite operation, though. What operation connects negative 2 and x? Multiplication. So what operation undoes it? Division by what is connected. If there's a negative connected, I must divide by a negative 2. So what's negative 8 divided by negative 2? Is it 4 or negative 4? It is positive 4. 2 negatives is an even number of negatives. So that's another rule that can get confusing. You say, well, I have my calculator, so I'll just let it do it for me. I would not rely on your calculator. I literally had someone last class say, well, when I put this in my calculator, I get a different answer. And I say, that's because you put it in there wrong. So your calculator, it does what you tell it to do. But if you put in a wrong sign or a wrong number, okay, that's going to lead you. You can do 8 divided by 2, okay? And don't put those negatives in there because, honestly, I see more mistakes happen when that happens. Okay, look at this next problem because I'm about to give you one in a minute, and I need you to get it right, okay? I had a lot of mistakes earlier, okay? So here's my next problem. What do you see that's different about this equation, Hadley? Not the answer, but it does look a little backwards, doesn't it? Because the x comes second. All right? And that's confusing a lot of people today. They're seeing this first number and they're saying, oh, I need to get that to cancel to the other side. And what I'm telling you is that's not how we need to look at this. We must look at the side with the variable no matter which side it's on. Just your attention, your focus needs to immediately be drawn to the side with the variable. Can you do that for me? Can you guys do that? Okay, so now that I'm focused on the right side of this equation, I know I need to get x by itself. That's my ultimate goal. I don't care about the 9, okay? That doesn't have anything to do with with my steps that I need to take. What's the first thing I would need to do? Okay, so now I'm going to kind of put this out to you. What do I do first? According to my steps, what would I do first? What would I cancel first to the other side? What would I do first, Alexa? Okay, very good. I would need to add 12. So she's focused on what is not connected to the variable on that side of the equation. It was negative 12, so I'm going to cancel that first. Is that what you were thinking? Mm-hmm. Okay. But whatever I do to one side, I have to do to the other side. Just make sure you do it to both sides. What's 9 plus 12, Addie? What's 9 plus 12? 21. Okay. What do I bring down on the right side of the equation? 3x. Okay. Are the clouds starting to part? Do you see what you need to do next? All right. Okay. Aaliyah, what do I do next? What? Yes, divide. She knew division because 3 times x is multiplication, so division gets it to cancel, not subtraction. Division. So 7 equals x, or you could have said x equals 7. Same thing. Okay? And guys, you can check this. What's 3 times 7? What's 21 minus 12? 9. 9 equals 9. I know that I'm correct. Okay? All right, how am I doing with whole numbers? Okay? So on your homework, it should not matter what side of the equation x is on. You know what to do. Right? Okay. So here come our fractions. Okay? Our pesky little fractions. And what our book teaches us is I don't like solving equations that have fractions, especially if there's more than one fraction in the equation, because I have to find LCD, I got to multiply by the reciprocal, there's all kinds of things going on. First of all, I need you to change, I need a variable in here, I need you to make it 4/5 x. Somehow our poor little x got left off, and We need a variable to solve for. Okay? So here's what our book tells us. And guys, this is a very important concept for us to learn. Okay? That instead of worrying about all our fraction rules, I kind of like the idea of clearing them, getting rid of them. Okay? And I get a fraction to clear by getting its denominator to reduce to 1. Because wouldn't you agree any number over 1 is just a whole number, right? Like 5 over 1. Please pay attention to this. This is important. Would you agree 5 over 1 is just 5, right? So if I can get my denominator to cancel down to 1, my fraction's gone. I need an LCD. I need to figure out the smallest number that all my denominators could go into. And guys, this is not going to be a super big number, okay? They're not going to make it that complicated. It's always going to be kind of a small number. Can anybody think of the smallest number that 2 and 5 would go into? Isla? No, the smallest whole number that 2 and 5 would go into. Aiden? 10. 10 is the LCD, okay? The smallest, you get what I'm saying? Multiples, okay? 10 is the smallest number, so here's what I do. I multiply 10 by each term inside the parentheses. That looks like distributive property. Okay, where did I get the 10? Can anybody tell me? Can anybody tell me where I got the 10? It's the LCM. Okay, so whoever just asked that, do you see where I got 10 from? It's the LCD. Now, I had the question earlier, what if I thought it was 20? What if I missed the LCD and I thought it was 20? As long as your denominators are canceling down to 1, you're going to end up with the right answer, but you're going to have bigger numbers. We don't want that. All right, so here's what we do. Are you ready? Are you paying attention? Okay, we're going to distribute the 10, which means I cross-reduce my denominators. 5 goes into 10 how many times? 2. So now 2 times my numerator. What's 2 times 4x? 8x. Does everybody see how I got 8x? Okay. All right, let me do the next one. Okay, cancel out your first 2. Now my second fraction, 2 goes into 10 how many times? 5. So 5 is what it cross-reduces to. And what's 5 times negative 1? Negative 5. Okay, so now I need to do it one more time. 2 goes into 10 how many times? Okay, 5. And then 5 times negative 7 is what? Negative 35. And now I have a 2-step equation to solve. Okay? So let's see here. Lydia, what would be my next step? I have 8x minus 5 equals negative 35. What's my next step? Very good. I need to now focus on getting x by itself. What do? I add and subtract first. What's not connected to my variable? Add 5 to both sides. All right, now here's where I have to fight this thought. Man, I'm supposed to have a whole number for my answer. But when I bring it down, I get 8x equals, what's negative 35 plus 5? It's negative 30. This isn't going to be a whole number. And that's okay. That's okay. Most of the time, guys, when you're solving equations with fractions, your answer will not be a whole number. All right, Maddie, can you bring it home for me? What is my last step to solving for x? Very good. And what she means by put it over 8 is what operation? Division. Dividing. Because 8x was multiplication, I have to divide. Can I reduce 30 over 8? Yes. By what factor? 2. Negative 15 over 4. Negative 15 over 4. Okay, so This definitely is not one of your easier concepts, agreed? Yes. Okay, so what I want to do is just take a time out, okay? I need you working ahead of me on this second one so I can start to kind of figure out where we're still, where we need to do some extra work. But I want you to try to find the LCD for the second problem. You guys can work together, put your brains together, put your heads together a little bit. Find your LCD and try to clear your fractions. Go ahead and clear your fractions. Okay, what was the LCD? Y'all tell me. 12 was the LCD, which means I must distribute it by every fraction. So 4 went into 12 how many times? 3. And then 3 times A was what?
3A.
3A, okay? Now, 6 goes into 12 how many times? 2. And 2 times negative 5? Negative 10. Very good. And then lastly, 2 goes into 12 how many times? 6. So 2 cancels, and 6 times 1 is? 6. Very good. Now, next step, Aiden Haynes, what do I do next?
You have to do plus 10.
Very good. Yep, very good. Plus 10. And this is where we don't panic that our answer is not going to be a whole number. That's okay. All right, let's see, Matthew, what's my last step? Divide by what? 3 both sides. And A equals, guys, I want you to leave your answer improper. And here's why. If you were to go back and check this, that's going to be a complex fraction, okay? If you were to go back and check this, it's easier to check it when it's an improper fraction. Okay, now if you turn that into a decimal, 16 divided by 3, you would have got 5.3 repeating. Okay, it gets a little complicated to check it, but it is possible. Okay, and again, it's not mandatory on your homework, but it's definitely a method that could help you just make sure you got the answer right. Okay, how many people got 16 over 3? Okay, great job, great job. All right, we're going to move on.
Oh, no.
All right, so what we see here, okay, and we're not going to get too deep into this today. We'll keep digging deeper, especially as we start solving inequalities in the distributive property. But what we see here, this is familiar to us because I can't combine my like terms, so I have to distribute the number on the outside with each term inside. Okay, can y'all go ahead and do that distributive property? So we're trying to get rid of that parentheses. That's what order of operations tells me to do. But because I can't simplify 4 plus z, they're not like terms, I have to distribute. Okay, negative 1/3 times 4, tell me.
Negative 1/3.
Negative 4 over 3. Keep it improper. Keep it improper. Minus 1/3 z equals negative 5 over 6. Okay, can someone raise your hand? What do you think could possibly be the next step? What could be the next step, Caleb? Yes, clear the fractions. Clear the fractions, guys. I don't want to have to worry about, when I'm trying to add 4/3 and finding. No, just find your LCD and clear these fractions out. Okay, go ahead and try to do that. All right, you can work together, absolutely. Okay, so the challenge in this was we had to do distributive property first. Now let's clear fractions and solve. Okay, what's the LCD? 6. Okay, now I had a question last hour. It was a good question. What if I said 12? If you said 12, you still will be canceling your denominators. You're just going to have larger numbers, but you still will get to your answer as long as you're canceling your denominators. All right, so the 3 cross reduces to a 2. What's 2 times negative 4? Tell me. Negative 8. Okay, so now 3 and 6. Okay, again, cross reduce to a 2. Minus 2z. Did you guys get that?
Yes.
2 times negative 1z. All right, and then now the 6's, well, what are the 6's reduced to? 1. So equals negative 5. All right, I need to just kind of gauge how you guys did. Who got that equation? Okay, I just need to kind of get an idea. If nobody's raising their hand, we need to stop what we're doing and Okay, good. All right, let's see. I need someone. Colin, what do I do next?
So you want to get negative 2z alone, so you would subtract 8 to get the 8 to cancel out. And then subtract 8.
Okay, you're close, but it's already subtracting, so you need to...
Oh, add.
Yes, very good, which is what I think you meant. All right, so plus 8. Negative 2z equals what, class? 13? 3. Whoever said 3. Divide both sides by negative 2. Z equals negative 3 over 2. Okay, did anybody get that right? Did anybody get that right? Or maybe you were on track to getting it? Okay, good. Good. Hey, take a step back. Was that an easy problem? No. Okay, if you're saying yes, congrats, because it's not, okay? All right, now, example 3. This is probably the last one that we have time for. We'll do the word problem example tomorrow. Combining like terms, which does mean I need to change your homework, but we'll get through example 3 first, okay? Combining like terms to solve. This is something you did in chapter 3, where before we start moving terms to the opposite sides, we need to make sure that there are no like terms on the same side of the equation that need to be simplified. Okay, so here we go. 3y minus 8y. Are those like terms? Yes. Absolutely. So I can combine them. What's 3y minus 8y?
Negative 5y.
Yes, negative 5y equals 25. And now you can solve. So you must combine like terms before you can solve the equation. All right, you go ahead and do the next step. All right, what do you do to both sides? Jack, what do you do to both sides?
Divide by 5.
Not the 5, but the negative 5, right? Okay, what did you get for your answer?
Y equals negative 5.
Very good. You guys agree?
Yeah.
Okay, very good. And yes, that's true. Negative 5 times negative 5 is positive 25. All right, let's look at the next one. All right, do you see any like terms that you might be able to combine before you start moving things? Yes. Rewrite. Okay, I cannot say this, okay, more like, what's the word I'm looking for? Please, okay, so I'm begging you. All right, maybe that's a good word. Please rewrite your equations. If you don't rewrite the equation, I've just seen a lot of mistakes happening. So 2y plus 7 equals negative 9. 2y plus 7 equals negative 9. All right. Go ahead and finish and compare your answers with your buddies. All right. Hadley, what do I do first? Guys, quiet. We're going over it. Shh. Quiet. Hadley, what do I do first?
We need to go to the positive 7 and subtract it.
Very good. Subtract 7. And then what did you do?
We're going to go to 9 and add that by 7.
Okay, so what she means by add, I think, I'm pretty sure, is the add and keep.
Yeah.
Yes, because I see 2 negatives, I need to add and keep to negative 16. Did you do that?
Yes.
Divide by negative 2, and I get y equals negative 8. Raise your hand if you got negative 8. Okay, good job. All right, so now, and this will be our last slide for today. What we see here, okay, is we see just what? What do we see? What do we see? Decimals and fractions with the combining like terms. And I know it's like, oh, why can't these just be whole numbers, for crying out loud? And honestly, guys, it's just, again, driving home that point that I can have decimals and fractions in my equations, and I still solve them using the same rules, okay? So the first thing I need to do is, yes, I need to combine my like terms, okay? Now, you are allowed to use your calculators. You could do 1.3 minus 2.1. However, this is different signs, right?
Yep.
You could just as easily subtract and take. Okay? Is your answer, when you subtract them, going to be positive or negative? 2.1 is bigger. It's going to be negative. Okay, so rewrite your equation. Rewrite your equation, guys. Okay, that was rough. Negative 8 equals negative 0.8 m. All right, I'm not going to say anything else. I want you to finish solving for m. When you have the answer, raise your hand. I want you to solve on your own, okay? Solve on your own, and then once you have an answer, you can use your table buddies, okay? Bounce your ideas, but don't do it until you have an answer, okay? Raise your hand when you have an answer. Okay, divide both sides by what is connected to the variable, okay? So here's where I still have a little bit of confusion. I need to clear it up, okay? I have some people who are thinking, oh my goodness, it's freezing. Don't do this to me, please don't. No. Okay, so I have some people who are saying, all right, sorry, my screen just literally cleared out of nowhere. So it might look a little weird up there. I'm going to rewrite it. Negative 8 equals negative 0.8 m. Okay? You must divide by what is connected to the variable. Okay? So if it's negative, you've got to divide it. Divide the other side by negative 0.8. M equals positive 10. Positive 10. It's positive because it's two negatives. Okay? It's two negatives. All right, we don't have time. We're running out of time. So let me just, guys, listen. The only difference with the last one is we do have like terms over here on the right side. Please pay attention. I still want you to clear your fractions. Okay? So don't worry about combining like terms until you clear your fractions. Can anyone raise your hand because they are pretty simple denominators and tell me what I would multiply by? Caleb? 4. I'd multiply everything by 4. That means negative 6 over 1. Well, what's 4 times negative 6? 4 times negative 6. Negative 24. Now, on the second fraction, my 4 is cross-reduced to a 1. So 1 times 1w is 1w. And then I cross-reduce my 2 and my 4 to make a 2. And 2 times negative 1w is negative 2w. And then I would just solve. Okay? I would just solve. Negative 24 equals negative 1w. Please hold on. Divide both sides by negative 1. W equals positive 24. Okay? Now, I rushed through that one because we're just out of time. But, again, it's just that concept of clearing fractions. We've done pretty much everything except the word problem. I'm taking off number 26. It's not there. So just look at the board. And I took off 37 because we didn't get to example 4. And I added in number 35. Okay? So it's 2, 12, 16, 18, 24, 30, 34, 35. I will update the portal after school. That's your homework due tomorrow.